thing, but the graph will look horizontal instead of vertical like this. And it would just be the same thing. X is 0 and y is 1. And x is 2 when y is 4. And x is 4 when y is 7. And you can tell the same information. You know, how do you get from 0 to 2? Well, I added 2. And how do I get from 2 to 4? Well, I added 2. And how did I get from 1 to 4? Well, I added 3. And then how did I get from 4 to 7? That I added 3. So the same information can be written both ways, whether it's vertically or horizontally. And they can be written as ordered pairs. So you have 1 ordered pair, 2 ordered pairs, 3 ordered pairs, or the same thing horizontally, 1, 2, 3. And these are all 3 solutions, but there's really infinitely amount of solutions along this line. It's just any point that's on the line. These ones are just really nice because they're whole numbers. All right, so moving on, we're going to talk about something that is called a rate of change. A rate of change is a ratio, and remember a ratio is where you have something on top divided by something on the bottom. Okay, you can write it as a fraction, or you can write it as a different way too, but we're going to be looking at it in the fractional view. So a rate of change is a ratio that compares the amount of change in a dependent variable to, 2 is the key word that tells you what goes on the bottom of this fraction. So a ratio that compares, after the word compares, that tells you what goes on the top part of the fraction. So the amount of change in a dependent variable, that's why we have rate of change equals, it's a fraction, right? Change in the dependent variable. That is the top part of the fraction, and that is right here, this bit right there. When you see the word 2, that's about to tell you what goes on the bottom part of the fraction, and it says it compares to the amount of change in the independent variable, which is this right here. Now, I don't know if you've ever heard of the terms dependent and independent variables, but really what that means is a dependent variable or change. What they like to use in mathematics is they use this like, I'm going to write the same thing. Well, I'll write in a second. They use a triangle, and that represents change. So change is a triangle, and the dependent variables, those are the y's. The y's are the dependent over the change in the independent variables are the x's. Okay, so rate of change is what really, that is the same thing as the slope. That's where you're going to be going. But it's what's changing. So back in this, this last example that we were looking at, okay, so if we talked about the rate of change equals the change in y over the change in x. Okay, well, what's happening? What's the change of the y? Well, here, the y is going up, 1, 2, 3 units, and then 1, 2, 3 units. We saw it there. It's 3 and 3. So that means that the rate of change, and I hope you don't mind, but I'm just going to write rate of change equals 3 over the rate of change for the x's. And what happened in our picture? The x's went over 2. It went over 2. And if you look here, yes, it increased by 2, the same thing. So the rate of change for this example would be 3 over 2. If we went and looked at the rate of change for this example over here, the rate of change is the change in y over the change in x. Well, what we had was something a little different. Rate of change, I'm just going to abbreviate. The change in y, here, it went up by 2, it went up by 2. Here, if you look in the table, which is the same information, just visually and more in a table, kind of more just numbers algebraically would be kind of more this. The y is changing by 2. It's a constant rate of change. So the rate of change would be 2 over the rate of change for the x's. If we look here, it was 3 every time. And if we look on the picture, it was 1, 2, 3, 1, 2, 3. So it's actually, I should have wrote it here, 2 over 3. That would be the rate of change for this particular problem. And that's kind of how you find that. All right, so we're going to go ahead and stop this video for right now. This is an introduction to Chapter 8.1, Graphing Linear Equations. So hopefully the little bit of street smarts helped you identifying what's a linear equation and what's not a linear equation. Also talking about linear equations and the solutions, knowing that any point along this line is a solution. And we kind of looked at some solutions and we talked about how we could graph them as ordered pairs, or we could write them in a table, a vertical table or a horizontal table that means the same thing. And then the last thing that we talked about was the rate of change, talking about the change in the dependent variable, which is the same thing as y, over the change in the independent variable, which is the same thing as x. So, and then we kind of looked at those back in our examples and found what the rate of change is. The rate of change is 2/3 for this one, and the rate of change is 3/2. And what you'll be learning very, very quickly is that the rate of change is really the slope, which means that we just found the slope. We found that the slope of this equation is actually 3/2, and the slope of this equation is the same thing as 2/3. And that's will be something that you'll be learning about very, 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 very soon. All right, we will see you next time.